So applying chain rule on trigonometric functions. So for instance, we are given y is equal to sine square x. Sine square x. This is our equation 1. But if we are given this, what we have to do is we know that this sine square is the same thing as saying sine x all square. So whenever we see sine square, then x is the same thing as sine x all square. But when we see sine x squared, this is different because here is the x that is carrying the square. So this is not the same thing as sine square x. So let's come back to this. Given this is the same thing as this equation 2. So we apply the chain rule. Chain rule says that we have to name the function inside, right? Because it's a function of the function. So we say let p equal to sine x. So let p equal to sine x. Then this shows that we have our p, which we can call it our equation 3. And then what will this one become now? This one will become p raised to the power of, because here we have said let p be what is inside. So this is what we have. So this becomes our equation 4. So if we are to differentiate equation 3 and 4, we said that the p all over the x, because this is p is a function of x. So this gives us the derivative of sine x equal to cos x. But note that the derivative of cos x is equal to minus sine x. So the derivative of sine x is equal to cos x. So this is the result for equation 3, which we name it our equation 5. And move to equation 4. Equation 4 is y, which is a function of p. And to differentiate y, we have to differentiate y with respect to p. So the y all over the p is equal to 2p. Then raised to the power of 2 minus 1. This is called the power rule, whereby the power comes down, you remove 1 from the power. And if you simplify, you get 2p. So this is our equation. Applying the formula of chain rule, which is that dy all over dx is equal to dy all over, here we differentiate y with respect to p. So it will be dy dp times, then we differentiate p with respect to what? X. So it will be times dp all over dx. Whereby if we cancel, we see that it's back to dy dx. And this gives us dy dp give us 2p times dp all over dx give us what? Cos, which means that, ready? So note that we have gotten our dy all over dx to be 2p equal to, we have gotten our dy dx equal to 2p cos. So therefore, this shows that our dy all over dx is equal to 2 times, what is our p? P is equal to sine x. So this gives us sine x times our cos x. So 2 sine x cos x. Now note that if you see these two guys, this is your final answer. You can leave it like this. This is your final answer. You get. But in case you want to modify it to really get a sensible one, maybe we can say therefore this is our final answer, or we can still modify it by saying dy all over dx is equal to, whenever you see 2 sine x cos x, the answer is the same thing as sine 2. Sine 2x is the same thing as 2 sine x cos x. The reason is because this sine x, now this is the explanation. Sine x plus x is what gives us this 2x, right? So this shows that we have sine x plus x is the same thing as sine x times cos x plus cos x times sine x. So if I have 2 here, it means sine 2 cos x plus cos 2 sine x. You get? Now if it is p here, it will be sine p cos x plus cos p sine x. That's how it will look like. So but here we have x and x. So since both of them are the same, right? Multiplication cos x and x is the same thing as sine x cos x. So this shows that from here we can actually say 1 1. So 1 plus 1 is what? 2 sine x cos. So this means that sine x plus x, which is the same thing as saying sine 2x, right, is equal to what? 2 sine x cos x. And that is what gave us this guy here or this guy. So this is our two answer. We can either write this or this, and that's the final answer.